So lastly, and arguably the most important thing that we're going to do with chemical reactions is to be able to predict the products of a chemical reaction. And it really does require a variety of things that we've already learned and combining them together in order to really be able to go through and write out these balanced equations. So let's walk you through it step by step on what we're going to do here. The first thing we need to look at is, based on the reactants, determine the reaction type. So remember, we've talked about the 5 different reaction types already. We talked about combination, decomposition, displacement, exchange, and combustion. We can determine what type of reaction we have solely based on the reactants themselves. So that's our very first step. Secondly, we want to be able to write out our simplest product form based on the reaction type. So if you remember, there were quite a variety of little miniature equations at the very beginning of each of the slides that showed the different types of reactions, like A plus B yields AB, or XY breaks apart into X plus Y. It's very, very important that you follow those steps and break them apart accordingly, but also we do not carry over subscripts unless we have polyatomic ions. Remember that subscripts are determined by whether something's a diatom or not, or by what other chemicals it's bonded to. Step 3 is to correctly write out the chemical in each of your products. So go through and balance out your charges, recognize your diatoms, all of that good stuff. And then lastly, balance your chemical equation. So if I look at the examples on the right-hand side, let's try to predict what types of reactions these are. We won't predict the products of these, but let's figure out what types we have going on here. The very first one is that we have 2 elements that are combining together, Mg and N2. So because they're 2 elements, they'll combine into one thing. So that is a combination reaction. The second one is an element and a compound. And again, if I go back and look at the other types of reactions we've looked at previously, we're going to know that that is a displacement reaction. The third and the fourth are similar in the fact that they're 2 compounds that are reacting together, so both of those are going to be considered exchange reactions. So again, we can determine the type of equation, what the type of reaction we're looking at solely based on the reactants themselves. If you need some help with that, go back, take a look, and see what formulas or what the basic formulas are for each of the 5 types of chemical reactions we're going to be looking at. So let's do a couple of examples of some practice problems here before we start moving forward and before I give you an opportunity to work on some of these on your own. So this very first problem here says that sodium reacts with gaseous oxygen. Let's take a minute and recognize what we do have. The first step is to determine the reaction type. And I notice that I only have 2 elements. I have sodium and oxygen. They're going to combine together in what is known as a combination reaction. So if I only have 2 elements to start off with, the only thing that they can do is combine into one thing. So therefore, I have a combination reaction. Second step is to write out the simplest product form based on the reaction type. No subscript carryover except for polyatomic ions. So if I start off with the materials, I have solid sodium, which is Na, and oxygen, which is a diatom, which is O2. And I react them to form my product. Now notice, no subscripts are carrying over. I'm just simply combining the 2 elements into one, and we'll focus on the rest of the part later. But again, don't carry over subscripts unless they are polyatomic ions. Step 3 is correctly write out each chemical in your products using your charges. So Na is a 1+ charge, O is a 2-, so we cross and drop. So our product is Na2O. And then lastly, we go through and we balance our chemical equation. So we have, looks like 2 oxygens on the left, 1 on the right. So a 2 goes in front of Na2O, and then we end up with 4 in front of Na. So again, it is a step-by-step methodical process that we work through in order to figure out how to go through and write out these balanced chemical equations. Now, that being said, I have some that I want you to try on your own, okay? Try these on your own. We have quite a few that we're going to work through. We'll do 1 page at a time, and then we'll come back and see how we do with this. So take a minute, and we'll be right back in just a moment. All right, so just like what we've done before, the first thing we need to do with each of these is determine what type of reaction it is. Potassium and bromine are reacting together. These are 2 elements. The only thing these 2 things can do is combine together into one thing. So this is going to be our combination reaction. Okay. Remember, when we combine 2 things, we're just going to do the simplest form of the product. So K and Br together, or metal before non-metal, just like we do with any of our compounds here. Now we just need to make sure we've written our products correctly. So check your charges, 1+, 1-, so we're good there. And the last step is to go back and balance it. So 2 Brs on the left side, 1 on the right, 2 goes in front of 2 KBr, and a 2 goes in front of K. So again, identifying the type is the very first step. Predict the products based off of the type, but do not carry over subscripts unless it is a polyatomic ion. Check your charges, then go back and balance. Hydrogen gas reacts with chlorine gas to produce one product. 2 reactants, 1 product. This is also a combination reaction. Hydrogen gas, remember it is a diatom. Chlorine gas, also a diatom. 1 product. Check your charges, so 1 plus, 1 minus, so we're good there. Now we go back and balance. Okay? I know they're pretty easy at first, but again, identify the type, form the most basic form of your products with no subscripts, determine the subscripts based on the charges, go from there. The third one here, we start with 1 reactant. The only thing we can do with 1 reactant is break it apart. So this is going to be a decomposition reaction. So start off with HI, break it apart, now go back and check your charges. But remember, we're checking for diatoms as well. Hydrogen and iodine, both part of Brinkelhoff. Go back and balance. Silver oxide is decomposed. It tells you right there what type of reaction it already is a decomposition. Silver oxide, Ag2O. Break it down. Any element by itself has no charge. Oxygen is one of our 7 diatoms. And now we need to go back and balance. 2 goes in front of Ag, and a 4 goes in front of the Ag here. All right? So again, step by step, we take our time, we work through it methodically, we figure them out, and we work through them, all right? Let's do a couple more. Predict the products of these chemical reactions here. So solid zinc reacts with aqueous sodium sulfate. So let's go ahead and write these out first, and that will help us figure out what types of products we're dealing with here. Okay. So notice that we have an element and then we're adding to it a compound. So this is an exchange. Sorry. This is displacement. Now to write the most basic form of our products, remember we have to figure out what this zinc is going to replace. Metals replace metals. Zinc is going to replace the Na here. So when I write my most basic form of my product, it is going to be Zn, SO4, and Na. They traded spots. They don't combine together, but they trade spots in this balanced chemical equation. We check our charges to make sure we've written everything correctly, which we have, 2 plus 2 minus, so we're good there. Na is not a diatom, so we're good there as well. And now we just go back and we finally balance our chemical equation. And we're done. All right? This next one here, solid iodine. So let's write this out. Again, writing out our reactants really helps us figure out what our products are going to be. Tin, 2 chloride, so that gives tin a 2 plus charge. Chlorine's a 1 minus, so 2 plus, 1 minus. So once again, we have an element and a compound. So this is another displacement reaction. This time we're dealing with iodine though. Iodine, if you remember, is a nonmetal, so it's going to trade places with chlorine because chlorine is a nonmetal. So chlorine is now by itself. And the tin and the iodine go together. Chlorine's a diatom, 2 plus, 1 minus, and we're already balanced. Okay, so again, recognize what type it is, exchange, and then go through it and write out your formulas correctly. Let's do one more. We have lead 2 nitrate reacts with potassium iodide. So again, write out your formulas. Lead 2 nitrate. Remember, always check your charges when you do this. Potassium iodide. Check your charges to make sure you're writing all your formulas correctly. My aqueous isn't that great written, but you get the idea here. So we have 2 compounds that are here. 2 compounds, you're just going to switch out whatever's negatively charged. So Pb is now bonded to iodine, and potassium is now bonded with nitrate. We check our charges. Okay. And then we go back and we balance. We have 2 nitrates on the left, 1 on the right, 2 goes in front. 2 potassiums, 2 goes in front, and the iodines are now balanced as well. So once again, determine the type, predict the products based off of the type of reaction, no subscripts unless it's a polyatomic ion, add subscripts based off of your charges, and then go back and balance your equation. It is a culmination of all of the different things that we have combined together. But if you know what we're doing, we should have no problem with this whatsoever. All right, let's move on.